Hey folks, today's topic is long and synthetic division. So this should be a review, in theory, of what we did back in early elementary school and how we did long division. So let me just do a quick review of how that long division works. So let's say we want to take the number 3,765 and we want to divide it by 7. So if you remember how to do this, go ahead. You don't have to wait for me. But if you need a quick refresher, we take this number and we try to put it into the first number here. So 7 doesn't go into 3, so then we treat 3 and 7 together as 37. 7 goes into the 37 a maximum of 5 times. 5 times 7. So once we figure out how many times it goes in, then we take this and we multiply it by this, and we put what its product is down here. So 5 times 7 is 35. And then we subtract. 37 take away 35 is 2, and then this 6 drops. Then we repeat the process. 7 doesn't go into 2, but 7 goes into 26 3 times. Then we take this 3 and we multiply it by 7, that's 21, and then we subtract. That leaves me with a remainder of 5, and then this 5 drops all the way down. 7 goes into 55 7 times, so that's 49. Then I subtract and we get 6. Now, because 7 is larger than 6, we call this our remainder. Now, when you're in elementary school, they used to let you just write R6 at the end, which I think is a little bit weak. It's definitely poor mathematics. What we should say is that the answer is 537, and 6 still needs to get divided by 7. So on the end of this, we put 6 sevenths. So 537 and 6 sevenths. We're going to repeat that process, but we're going to do it for a polynomial. So I want to divide this polynomial by this polynomial. So just like we did here, I divided 3,765. So that's the part that goes in the house. So this is what I'm dividing. This is what I'm dividing by. So this is what goes in the house. Leave yourself a little bit of room because you're going to have to write, just like we did the 537, we got to write that up above. So the x minus 2 is going to go out in front. And then the 6x cubed, subtract 19x squared, plus 16x, subtract 4, goes inside the house. And I'm going to do this using colors. So over here, the first thing I tried to do is I tried to turn 7 into 37 as many times as I could. We're going to do the same thing here. I'm going to try to turn x into 6x to the third. Or another way to think about this is I'm going to divide 6x to the third by this x. Don't worry about the minus 2. That'll come into play later. All we're going to worry about is the first thing here and the first thing here. So this is getting divided by this. If it helps you understand it better, some kids like to write it over here what they're dividing. 6x to the third is getting divided by x. So as we clean that up, I can kill off one x and I get 6x squared. Just like over here, I would say what's 37 divided by 7? We got 5. That goes up here. I'm going to take the 6x squared and put that here. Then what did we do over here? After we figured out that 5, we took this 5 and we multiplied it by the 7. So I'm going to take this 6x squared and I'm going to multiply it by this divisor. This is where that minus 2 comes back into play. So that 6x squared is going to get multiplied by x, but we also have to distribute it to this piece as well. So we can't pick and choose here. We have to distribute this to both of these terms. So 6x squared times x is 6x cubed. 6x squared times negative 2 is negative 12x squared. All right, so now over here, I'm going to refer back to what we did here. After I did 5 times 7 and I got 35, what did we do next? We subtracted. So I need to take this orange expression and I'm going to subtract the green expression. Well, the easiest way to do this is this saying that I came up with. When we draw the line, you should switch the signs. That means you got to switch both of the signs. So I switched this 6 to being because I'm subtracting, it's going to change both those signs around. Now we can just combine 6x cubed minus 6x cubed is gone. Negative 19x squared plus 12x squared is negative 7x squared. And then what did we do with the 6 and the 5? Because we didn't divide those yet, those dropped down. We're going to do the same thing here, except I recommend dropping everything, not just the next term. Then after we had the 26, we repeated the process. So I'm now going to take the first thing and I'm going to divide it into the first thing. So for us, that would look like negative 7x squared is getting divided by x. So one of the x's cancel out, and I get negative 7x. That then is my divisor. My bad. That's my quotient. That's what I'm dividing into. Now I take this and I'm going to multiply it by both of these. So negative 7x times x is negative 7x squared. Negative 7x times negative 2 is positive 14x. What's the saying? Draw the line. Switch the signs. So those would now cancel, and I would get 2x subtract 4. And then we would repeat the process one more time. So the first thing is 2x. I'm dividing that by x. So those would cancel. I'm left with just the 2. That's a positive 2. I'm going to take this 2. I'm going to multiply it by both of these. So that would be 2x subtract 4. The saying again is draw the line, switch the sign. So this would switch to a minus. This would switch to a plus. And we get a remainder of 0. So then our answer, when we divide this expression by this expression, we would get 6x squared subtract 7x plus 2. All right, let's take a look at the next one. Now, before you get going too far, you got to be careful here. You've got to make sure that we have every term accounted for. Notice this one, x cubed, x squared, then x, and then just the constant. As I start to divide this, the 3x minus 2 is still going to be out front. That's not a problem. But then when I divide, I've got to make sure every term is accounted for, even ones that aren't there. So x to the fourth, the next thing should be an x to the third. So negative 9x to the fourth plus 0x cubed. So I've got to account for it, but I have to account for the x cubed, but I can't have it be worth anything. So if I put a 0 in front, 0 times this really means there's nothing there. Plus 22x squared. I'm missing an x term, so I'm going to put another 0x and then subtract 12. Now, as we start to do this, you'll see why we need to have that x cubed term. All right, so here we go again. First thing. So negative 9x to the fourth divided by 3x. Negative 9 divided by 3 is negative 3. X to the fourth divided by x is x cubed. So I get negative 3x cubed. Now I'm going to distribute this to both of these. So I get negative 9x to the fourth. Negative times a negative is a positive. 3 times 2 is 6, x cubed. See why we needed that x cubed? If we didn't have that 0x cubed there, this term and this term would not be able to be combined. So you must write it. All right, we need to subtract, which in my head means draw the line, switch the signs. And instead of scribbling out a negative, I just throw a negative in at an angle. So these cancel, and then I would get negative 6x cubed. Then everything else drops, because I still have to divide the rest of this. Then again, first thing. So my first thing down here is negative 6x cubed. Divided by my first thing is 3x. Those turn out to be negative 2, x squared. So that's now my new term in my quotient. Take this, distribute, so that would be negative 6x cubed, positive 4x squared. What's the saying? Draw the line, switch the signs. So 22 take away 4 is 18. And here we go again, first thing into first thing. So my first thing is an 18x squared, getting divided by a 3x. 18 divided by 3 is 6. X squared divided by x is x. So I would get a positive 6x. Take that now, distribute. 18x squared minus 12x. Draw the line, switch the signs. So I would get 12x, subtract 12. What color can I use here? I guess maybe a brown. How about that? So first term is 12x divided by 3x. 12 divided by 3 is 4. X divided by x cancels out, so I just get plus 4. 4 times 3x is 12x. 4 times minus 2 is minus 8. Draw the line, switch the signs, and we get a -4 at the end. Now, this has a degree of 1, 3x to the first. This is just -4, x to the 0. There is no x term, so that's kind of like up here. We ran out because 7 was bigger than 6. We can stop when we divide polynomials when the degree of the divisor is bigger than the thing we're trying to divide by. How do we write this, though? We write it the same way we did here. You take that remainder and you divide it by what you were dividing by. So my best full credit answer would be -3x cubed, subtract 2x squared, plus 6x, plus 4, plus, and I always put a plus, and I don't care if that's minus. In this case, you could get away with it. It gets a little complicated when there's more than one term, but whatever. So -4 over, now what are we dividing by? 3x subtract 2. So that's what a remainder looks like in the world of polynomial division. Let's have you pause here and try to do the last one on your own. Okay, so I'm going to take this as my divisor. So x squared plus 2x plus 1. Dividing into 3x cubed. Oops, I don't have an x squared, so I have to create one. I have an x, and I have a -2. All right, here we go again. First thing. So that's 3x cubed divided by x squared. So that's 3 with an x. So I get 3x here. 3x times x squared is 3x cubed. 3x times 2x is 6x squared. What's the saying? Draw the line, switch the signs. So this would be a -6x squared plus 4x subtract 2. We go again. First thing. So -6x squared is the first term here. X squared is the first term here. The x squareds cancel, and I get -6. So I could put a -6 here. Distribute to all three. So that would be -6x squared minus 12x. Subtract 6. Draw the line, switch the signs. Plus, plus, plus. So this would be 6. Where did I mess? Oh, I didn't distribute up above. I fell for my own. I didn't follow my own rules. Sorry. Go back. -6 times 1. This should be a -6. My bad. This is 3x. This is the green line. My bad. I wish I could start this over. 3x times x squared is 3x cubed. 3x times 2x is 6x squared. 3x times 1 is 3x. Now, when I draw the line and switch the signs, this is going to subtract 4 take away 3. This should be 1x there. Okay, now I did that the next time. I caught it the next time through. So these cancel. X plus 12x is 13x. -2 plus 6 is +4. My degree here is 2. My degree here is 1. So I can't divide any further. So my answer would look like 3x subtract 6 plus, take your remainder, put it over your divisor. X squared plus 2x plus 1. Okay, so that's called long division. Now, there is a short way to do this. It's called synthetic division, and that's what the other side is talking about. But synthetic division only works in certain scenarios. So synthetic division only works if divisor has a leading coefficient of 1 and degree of 1. So as we're looking at this example, let's take a look. Let's see here. This is my divisor. What's my leading coefficient? 1. What's my degree? 1. So I can do this synthetically. I'll talk about it in a minute. So let's set up synthetically. What I have to do first is I have to take this and turn it into a 0. So right now, this is what we call a factor. I want to identify the 0 that's associated with the factor. So if you want to find a 0, we just ZPP this, set it equal to 0. We would get x equals 2. So 2 is what goes in this little house. Now I'm just going to list the coefficients. 6, negative 19, 16, and negative 4. Leave a little space. And then the process is, this one will always drop. 6 drops. 2 times 6 is 12. Negative 19 plus 12 is negative 7. 2 times negative 7 is negative 14. Add them up. 2 times 2 is 4. Negative 4 plus 4 is 0. Now, this was an x to the third. We divided it by an x, which is going to make this answer have an x squared. So we would get 6x. This thing then can be rewritten as 6x squared subtract 7x plus 2. And if you notice, as I flip this over, that's the same answer we got here when we did this by long division. So I purposely picked an example that we could do both directions. Now, could we have done this by long division? Sorry, synthetic division. No. Coefficient is 3, not 1. So no, we have to do this by long division. Could we have done this by synthetic? No. Coefficient is 1, but degree is 2. We'd have to do this by long division. We can only do synthetic if our divisor has a coefficient of 1 and exponent. Degree of 1. I shouldn't say just exponent. So let's have you pause here. Don't forget your zeros. Have you pause there, see if you can do that one. All right, let's see how you did. So first of all, leading coefficient 1, degree 1. Now I need to turn this thing into a 0. I need the 0 in the little house, not the factor. So when I ZPP that, I get x equals negative 4. So negative 4 is going to go in the little house. My coefficients are 1x to the fourth. I don't have any x cubes. I don't have any x squareds. I have 46 x's, and I have a negative 5 as my constant. Leave a little space. Okay. First one drops. Then I multiply. Combine. You don't have to switch signs in this case. We already switched the sign when we found the 0 as opposed to the factor. Multiply, 16. Add them up, that's 16. Negative 4 times 16 is negative 48. 46 take away, nope. Negative 4 times 16 is negative 64. How about that? 46 take away 64 is negative 18. Negative 4 times negative 18 is 72. Negative 5 plus 72 is 67. All right, so now we've got to convert this back into a polynomial. So this is x to the fourth. We broke it down by an x, so this is now going to be an x to the third. So that's 1x to the third, subtract 4x to the second, plus 16x, subtract 18, and then all of a sudden we're at this spot. Well, this is our remainder. So if you remember, what we do with the remainder is we write plus 67 over the remainder over, and then go back to what we divided by, and what we're really dividing by is x plus 4. All right, so on the homework, most of them you can do synthetically, but a couple you have to do by long division. Good luck.